In 7.3 development and testing, first of all, we are going to understand the difference between the development and testing. So, I can say that development is a process where I am creating or constructing a software, or I am constructing some modules that are responsible for my software. A development can be for any purposes, like I can create softwares, I can develop softwares, or I can even develop the prerequisites or data structures, my data, or anything related to my software so that I can test it. So, developing and testing are two broader terms, but the difference between both of them is that in development, I am preparing, I am constructing a piece of software or anything I'm working on. Whereas in terms of testing, the difference is that I am not developing or preparing. I am only testing. I am only checking that if it is correct or not, right? So this is the basic difference between development and testing. So why there is a need for testing? So we have discussed in our program design life cycle all of the stages. The analysis stage we have discussed it, the design stage we have discussed this too, and now in the third stage, which is the testing stage. This comes after your design stage is completed. It is then necessary to create the system and fully test it. Now, this section is going to consider that how the development stage and testing is going to be implemented. So, to test it, I will be testing it to check that if the system contains some of the files, for example, a database, then the file structure is going to be finalized at that stage. And then once the data structures are fully created, so they can be tested to check that if I'm able to work with them or not, right? So the testing also works with your data structures, as I discussed with you. And the second point, it is equally important that the correct data is stored in file. There can be certain techniques be adopted to create some data so that they can be tested, and I have discussed with you regarding these validation routines, right? So I use validation routines to check that if my data is correctly added or not by specifying their fields. Like for example, if it's a phone number, it has to be in digits. If it's a name of any person, it has to be in alphabets or capital letters. The third point for testing states that a system is going to have some form of user interface. So there can be different types of hardware devices and how they interact with each other, how the screen and other systems are using to collect the data, and if there is any specialized hardware or not. So I need to test all of these things, right? This is the reason that why I need to test the data. I'm repeating it again. My point number one. First of all, I'm going to test my database. I'm going to test my data structures, file structures, such as my Excel, such as my spreadsheet. We discussed right here in these examples for the Excel sheet, right? I discussed with you regarding these data types. We discussed the file structure and the data structure in the design area, that I have products, I have fields in my last lecture. So in this testing part, I will be checking that if my data is correct or not, if it's fully tested or not, if I'm able to work it or not. The second point, I check with my that if there is correct data entered into my fields or not. And the third way, that why there is a need of testing, I can say that there can be some sort of hardwares as well, such as input devices, output devices. I can test their interface, I can test their hardware, that how their screens are working, how their input devices are working, how their output devices are working, right? So is it clear to you that why there is a need for testing? Should I go ahead?
Yes.
I explained you here 3 points. Just as the class and I will be asking these three from you. Okay.
Okay.
Now, in the second stage, we are discussing about the test designs. Now, Why test designs are considered, like they can be considered so that we can achieve the following tasks. Test designs are considered so that I can make sure that my data structure is working okay. I can make sure that my file structures are working correct. I can make sure that input methods are working correct. I can also make sure that output formats are working correct. I can also make sure that my validation rules are working correct or not. So this is a criteria, this is a way that why there is a need for design, for test designs, right? For example, in your data structure, my test design could determine how I can test all of the given data if it is in a correct format or not. For example, I shared with you earlier regarding the example of phone numbers or contact numbers or names. How can I design file structures? Beta, file structures can be tested in a way that if they are working correct or not, if the data stored in them is in the correct format or not, data stored is in correct format or not, file structures working correctly or not. In data structures, all data is in correct format. Input formats, in input format, I can check that how we can test that all data can be entered to the system correctly. Output format can be how can we test that the screen output are in correct format, and when validation routines to check that what data is needed to test to see if all the validation rules work. So can you define me the difference between data structures and file structures? In testing strategies, your softwares are often developed in modules. What are modules? Modules are different parts of your softwares. This method allow your software to be broken down into a number of parts, into a number of areas, which are known as modules, whereas each module can be worked by a programmer to check that if it functions correctly or not. Once the development of each module is completed, then the whole of the system is again and again tested to see if it is working correct or not. This can lead to improve many of the functions such as input output process if it is working or not, right? For example, in this diagrammatical representation, you can see that I have different module. This is your module 1, this is your module 2, this is your module 3, this is your module 4. Your module 1 can be modified if there are any errors that are found in your testing process. Same as goes for the second module, same as goes for the third module, and same as goes for the fourth module, that I am repeatedly testing them again and again, again and again, again and again to check that if they have any errors or not. So when they combine together, they create a final program. However, modify final programs if any errors are found as well. Let me show you another example of this as well. Yes, right here. Can you see that I have an example of an alarm app, and this alarm app is broken down into a number of parts, into a number of stages, into a number of modules, or into a number of functions. For example, I can say that this alarm app is divided into set alarm, check time, or sound alarm. These are the modules, these are the functions, and further they are divided into their subsystems as well, such as set time, such as turn it either on or off, such as you can play the sound for 2 minutes, such as on or off, or such as if you want to reset or if you want to check your alarm or not. So these are some of the example of your Lara map, because the same is that we are discussing right here, that in your testing strategy, what you do is that you develop your software in modular form. What is this modular form? This is just right here. As you can see that I have different modules for each of the program. They can be broken down into smaller parts known as modules, and each module can be developed separately by the programmer. Just as it is completed, each and every part, each and every module is tested, so that I should be knowing that if it is working correctly or not. Just in case if it is not working, it is improved, it is tested. So all of these modules are to be created as a one software, as a one function, and their verification and validation if process is done, so that I can check that if they have any error or not. So is this clear to you? Do you have any confusions?
No.
Now in the test plan and test data and live data, now I'm going to discuss this. So once the testing design and strategies have been determined is that first we also need to know that what are the design and techniques and strategies that we have to work on. Then it is necessary to create a test plan for each module, so that I can know that what are the list of tests I need to perform, what data is to be used in the testing, and what type of testing the data is designed for. Such as, okay, so I'll discuss this with you, that what are these three types of test data, and what data you would be using, what expected outcomes, what do the actual outcomes so as well. So whenever you are working with your data, you have different examples. The first example of the data is a normal data. So normal data is are all those values and ranges that are acceptable, that are valid, that are known. For example, if you are working for a number of years, for a number of months in a year, so you know it already that the expected value you are going to have is going to be any value from 1 till 12. If anyone enters the value 13, you would know that this is not a correct value, because there is no 13 month in a year. If it is an example of an extreme value, so an extreme value, this is data at the limits of acceptability or validity. For example, if you are working for a number of years, so if anyone enters 1, or if anyone enters 12, that is also accepted. However, it is an extreme form. The third area is the abnormal. Now, this is the data outside your limits, outside your accepted, or outside your validity, that should be rejected or might cause you an error. For example, any value that is less than 1, any value that is greater than 12, any value that is not acceptable. So this is your abnormal data. So once a system has been fully tested, it can be tested with live data, and this data with known outcomes as well. So you should be knowing that which type of data is understandable, which data could be accepted. So this all works with your testing phase. So why there is a need for testing? There is a need for, because just after you have created a system, you can test it fully, and just after your testing, you can also check that if your file structures are correct or not, if they are finalized or not. For example, what data is stored in your each field, if it is correct or not. You can also check by going through different tables that if it is working or not, and you make sure that you do not have any unnecessary or unwanted data as well. You can also test that if you have any extra hardware, or if you have a hardware such as a keyboard, mouse, input device, output device, you can check that if these devices are working or not. For example, you can check that if your scanner is printing is working or not. This is the reason that why I need testing. However, to design your test, there can be certain ways, like first of all, you are going to test your data structures. your file structures, your input methods, your output format, and your validation rules. I discussed with you why data structures, how can we test data in, if I just want to make sure that if it is in a correct form or not, your file structures to check that if they are functioning correct or not, your input formats to check that if they are entered correctly or not, your output formats to check that if the screen or the result is showing you correct or not, your validation routines to check that if your data system is accepting that reasonable data or not. And then I discuss with you regarding the testing strategies that just right here, that to create a software or program you need to break down your program into sub modules, into parts. And why is that? So that I can create the program, I can test them individually. And testing is obviously a very time consuming process, because you need to test your data with the possible data again and again, again and again, to check for errors. Regarding possible data, I discussed with you the four types of data, such as normal, extreme, and abnormal data. I perform this to check that if I'm having the expected outcomes or not, or if I'm having that exact data or not, or am I doing the correct way or not.